Hi, here we have a question from Leningrad Mathematical Olympiad, year 1964. This is for 8th grade and is relatively easy question. The question says, find all prime numbers p, q, and r such that we have p times q times r is equal to 5 times p plus q plus r. Maybe I spend 5 to 10 minutes, try to solve the exercise, and then come back and see the solution. All right, let us see how we can solve this exercise. Because we know that PQR is equal to 5 times something, that means 5 divides P times Q times R. And because these numbers are prime number, that means 5 has to divide one of them. Let's say 5 divides R. This is prime and 5 divides it, therefore that number has to be equal to 5. So R is equal to 5. We can put it in the main equation, simplify. We get P times Q is equal to P plus Q plus 5. Because it's a symmetrical structure we have, we can assume that Q is equal or larger than P. And now I also assume that P is equal or larger than 5. First, we assume this part, and then we consider the other cases, which are P equal to 2 and P equal to 3. Okay, so now we have also this assumption, P is equal or larger than 5. If this is the case, P times Q will be certainly equal or larger than 5Q, because this is P is equal or larger than 5, therefore this becomes equal or larger than 5Q. But if you look at this side of the equality, this is certainly less than or equal. Instead of P, I can put Q. So 2Q, instead of 5, I can put again Q. So this will be equal or less than 3Q. So this side is equal or less than 3Q. This side is equal or larger than 5Q. Therefore, this cannot be true, and therefore this is a contradiction. So if P is equal or larger than 5, certainly we don't have any solution. All right, so we know that P times Q is equal to P plus Q plus 5. And we said that P cannot be equal or larger than 5. Therefore, P has to be equal to 2 or equal to 3. If P is equal to 2, we put it in the equation. 2 times Q is equal to 2 plus Q plus 5. Q with Q disappears. Q becomes 7. So that is one solution. If P equal to 3, we put it here. 3Q is equal to 3 plus Q plus 5. Q becomes 4, but this is contradiction because this is not a prime number. Therefore, the answer that we have, P, Q, and R should be equal to 2, 7, and 5. But actually, any combination of these could work. So you could put, instead of P, you can put 5, 2, and 7, depending on how you select. All of the answers are correct because this is very symmetrical equation. All right, let's see what we have learned. First is that if we have a prime number and we know that another number C divides that prime number, it means that C has to be equal plus or minus 1 or plus or minus P. Check the special cases for small numbers. So always try the first few numbers. Maybe you get some ideas what the solution will look like. And the last point is investigate whether one side of the equation becomes larger than the other side under a certain constraint. All right, so that's the end of the video. I hope that you learned something new. See you next time. Bye.